Hello, Math 1332 students. Question came up about a problem on my math lab, section 8.4, number 49, that's very similar to this one. So let me walk you through this one. Suppose parents wish to have $200K set aside for their child's education within, say, 10 years. They've found a certificate of deposit, a CD, with an APR of 4.5%, compounded quarterly. How much should they deposit now? What one lump sum should they deposit now to have $200,000 in 10 years? Okay, typical question. So if you are looking into my math lab, help me solve this or show me an example. The way they are doing it there, slightly different than I've shown you in class. We can talk about that method too. But if you use the regular compound interest formula, but you solve for P, right? So there's this big thing multiplied by P, and if we want to solve for P, then we need to undo that by dividing both sides by P. By 1 plus R over N raised to the NT. And so if you do that, if you divide both sides by that, then you're going to have A over that quantity. And so you get a formula for just P. So now you have a formula to use where you plug things in on the right-hand side and out comes the answer on the left, right? So the interest rate would be 0.045. Compounding quarterly means n is equal to 4. Doing this for 10 years. So you plug those in, okay? And I just wanted to review for you again, maybe with better resolution, what the process of entering something like this in the calculator looks like. Okay, so how do we enter that? All right, so let's see how good this is looking to you. I'm hoping it's looking okay. To enter this, I would first start with the most complicated part, is the 1 plus the 0.045 divided by 4. That's inside that set of parentheses. Whenever you have a big fraction division symbol like this, that long line suggests you're supposed to divide this by all of that. So it really implies that there's another set of parentheses there. So PEMDAS says you see parentheses or grouping symbols, go inside and look for more parentheses. Here it's an exponential expression. We always have to enter the base before we enter the exponent. So that's where we're going to start. So I'm going to enter 1 plus 0.045 divided by 4 and get that quantity. Right? So that's what I've done so far, is this part. Just entered that. That's what's in my calculator right now, so I'm using that alternative color to keep track. So I look back at that, what do I have to do next? That needs to be raised to the 4 times 10 power. So I raise it to the, and my calculator, I'm in tiny font up there, so it's like being inside parentheses, but I could also add them. For those of you who don't have that, you would have parentheses 4 times 10, and parentheses, checking, and enter. And now I'm getting this. Okay, what is that? So that is representing, that's the calculator's approximation to all this. But this is in my denominator, right? So let's go back over that thing I was talking about in class. Recall that anything raised to the -1 power is really 1 over that thing. Or another way of looking at it, if you have 1 over something, like say some quantity 0.639, then if you want to bring that up into the level of the numerator, you just rewrite it with a -1 power. So let me just put a 1 on this so it feels more like the quantity that we're dealing with here, which is 1.56. That's what I have in the denominator on this problem. So 1.56 being in the denominator is the same thing as 1.56 being in the numerator, but with a -1 exponent on it. So if I have 200,000 over approximately 1.56, that's the same thing as bringing that 1.56 up here with a -1 power and multiplying it by 200,000. So that is what I'm going to do. There's my denominator quantity, 1.56, and I'm just going to raise it to the -1. Make sure you're using the negative, not subtraction symbol for that negative. -1 power. Now it looks like 0.639, and that is this quantity. This thing raised to the -1 is now up here, and now I multiply it by the 200,000 times 200,000. 2 with 5 zeros, and I get this. 127,846.4317. So now you're seeing the result, all the digits. In case you're wondering if you've been using your calculator correctly, you can check you're getting as much accuracy. And of course, we write this as $127,846.43. And that's what should be deposited today to have 200K in 10 years if you're dealing with an APR of only 4.5%. Alrighty. One more look at the final sentence. Okay.